Alright, making a response video of sorts. Might take a few videos on this subject to get through this. So that John Chappell Natural Philosophy Society, their Saturday chat, has been quite horrible of late, and so I was giving up all hope. But Franklin presented a paper, Franklin Hugh, who's at least one respectable character of the bunch, more than others anyway. You know, all dissidents are dislikable for one reason or another, frankly. But anyway, proposing that electromagnetic waves are at minimum, I would go a step further, that they are at minimum no different than sound waves, or other wave mechanical things, in the sense that they don't have any of these special properties they give. This electromagnetic field thing doesn't really have anything to do with it. There's no special fields. I would argue that the very concept of wave is where the whole thing falls apart, because all waves are emergent phenomena. They aren't elemental functions. Nothing is elementally a wave. It's always in something. It's a property of something. And even to call it a compression and a rarefaction doesn't say anything. I mean, kind of obviously I can have things separated by a distance, and then I can have more stuff in a smaller amount of space. You know, the stuff doesn't change, it's just that I have more of it. And that's what happens like with water. Water is just displacement. You take water that was mixed here like this, and you'd say, no, pile up more of it here, you know, and less of it here. More, less, more, less. That's all you're doing. That's all the wave is made out of. More water in one spot, and if it's a traveling wave, the moreness just is moving in a direction. It's not a big deal. It has momentum. You don't need a special word for that, you know, in the sense of a word that you're going to apply to other locations when things are moving and call them waves. And again, the grossest example is the electron, where it has a speed, and they've decided to wave its speed. So they're basically saying when a car is going 60 miles an hour, it has a frequency. It's waving at 60 miles an hour. They did the same. It's completely, you know, doesn't make any sense. There's no waving. It has no frequency. So anyway, yeah, so there's so much crap built into the language, the you know, bad semantics, bad verbiage, bad definitions, and then just nonsensical descriptions of reality. So anyway, so this will take a while to play this. I mean, he goes through he wrote a little 3-page paper making this argument. I don't agree with it entirely, but I agree with the premise of it, which is the first premise, which is there's no electromagnetic fields at all. Just nonsense. Garbage, rubbish.
For that. And so for this meeting, I'll first go through this.
I do have it sped up quite a bit, so no offense. And you know, the hope would be is that Franklin might respond. So I guess I will at least email him the link to this video. And I don't know why he doesn't present any of this on his own channel. It'd be kind of nice to be separate from this group thing, this whatever, this little Nazi organization of fascist religious kooks.
Paper. Now, if you have questions, can you please put those in the group chat? And if I see them, I'll get to them. But first, please let me get through the paper as just a regular presentation, since there have been some complaints that there have been so many questions during the middle of presentations that it was kind of hard to keep track of what's going on.
Yeah, so that was a good plan, is not to have people interrupted. I mean, still, presentations probably shouldn't be this long, but regardless, because, you know, you really can't get past opening the door. As soon as you say the first sentence, yeah, there's already people disagreeing. They don't want to hear the argument. And the counters to the way Franklin was treated after presenting this theory was hilarious, in the sense that it was just so erroneously not even close to the subject you know, and offensive, especially the hairy guy who's just an obnoxious troll. He's just trolls the room. I don't know what his point, what his place is here. What is he doing except trolling every single person who speaks, except for the religious kooks.
So please put your questions in the group chat. Like I said, if I can in line get to them, then I'll do that. Or otherwise, hold your questions to the end, and then we can start our discussion then. So this is my new paper, hot off the presses. Just finished it last night, which proposes the electromagnetic wave as just being exactly the same thing as an ordinary sound wave. So I start off this paper by asking the question, what's wrong with this picture? So here we have the standard mainstream description.
All right, so I guess I'll draw that just to be clear, but it's probably not necessary. But most of the people listening probably already understand these concepts. But it's the standard argument about this wave being, two kinds of waves, and this magnetic one going in one direction. Oh, that didn't come out very bright. Oh, that wasn't good either. Yeah. Well, anyway, and the other wave is, going like this. So one wave is this way, and the other wave is in the other dimension. So they're perpendicular to each other somehow, and also this way. Some wave is missing here. I don't know exactly where I missed it, but it should be going this way, I guess. And then this one here. Okay. Anyway, that stupid thing, the perpendicular this way and this way kind of nonsense. Anyway, I had better pens than this. I guess that one wasn't tried yet. Anyway, needs more work. Needs more work. Yeah, he should have zoomed in on his paper better, but minor details.
What we think an electromagnetic wave is. And in the picture you can see there's some red lines, and that represents time-varying magnetic field. And then we see blue lines, which is a time-varying electric field. And what this picture is supposed to be meaning is that you see this electric field which rises in intensity. You get electric field rising in intensity, heading in that direction. I mean, I suppose, if there were charges present, there would be plus charge here and a minus charge here, well, I don't know. This is kind of hard to understand, but the field strength is increasing, decreasing, and we have a magnetic field here, which is also increasing, decreasing. That would be like what you might observe between the North and the South Pole. So somehow it's increasing and decreasing, and this is based upon the equations of Maxwell, which predict that a time-varying electric field is associated.
Right. Well, I don't know about what it predicts, so that's a tricky word. It's conformed to an image of reality. And obviously I would make the simple argument, there's only one field, and it's, there's only one field. So there's this two-component thing is completely unnecessary if they just make it one thing. Just get rid of the B and the E, and just recognize that when you have monopoles, you have a different R number. It's R squared. And when it's a dipole, it's R cubed, that kind of thing. There's just certain little rules, but it's just one field. The B and the E are not different things.
With the time-varying magnetic field. Now, I would claim that this conception is purely theoretical and really only exists on Blackboard equations. And nowhere has anyone shown experimentally that these rising electric and magnetic fields actually exist in a traveling radio or light wave. I think fundamentally we are quite capable of measuring them. And if I put a magnetic detector as this wave travels by here, I should be able to easily measure the rising and falling magnetic field.
So again, he's still talking as if this is a wave of something. So he fills the universe, which he will speculate about, with neutrons, which I don't think works. And so this would just be clumping, compressing of neutrons. So you'd have a bunch of free neutrons. This is ether theory. I mean, you can't get around it, and I just think it's totally superfluous. It's just adding something that doesn't need to exist, because you're still going to move these bits of stuff. And so all you're really doing is saying a wave is where two of these get compressed together, and then that compression moves to these two next to it, and then it moves to these two, and then it moves to these two. So you're just talking about, well, there's twice as much stuff here as there is here per unit of volume. And so that's your wave. Your wave is a clumping of stuff, a gathering of it. And that's all that's happening with sound, is the molecules, the atoms of the medium. This cap won't go back on. Oh, it clicks. Oh. You know, sound is just a bunch of individual atoms being clumped. And the difference is that in most substances, even the atmosphere, there's some attachment between the molecules. So when one moves, the other one's shear with it. They can be, you know, they're pulled on. They have adhesion. So they have a kind of friction. And that's, of course, what creates round waves is friction. You know, a flat wave goes in and the surfaces create friction and it slows it down on the sides, and that's what curves the wave. But it's not really a wave, it's just individual atoms compressing at different speeds. You know.
But as far as I know, we've never ever really done that. So it's kind of curious. We believe in something which is, like I said, basically completely theoretical, but never backed it up with an actual experiment showing that this is actually what happens.
Yes, I mean, there's just nothing to connect it to reality. I found it totally, the minute I heard it, I just, as a kid, I was like, that can't be the right answer. It's just, it's too, you can't connect it to anything. It doesn't make any sense. A photon is doing this kind of, and then it's clumping a non-existent thing. It's, what is this? This isn't an answer to the question. It's junk.
The other main problem with this picture is that mainstream fundamentally doesn't even know what an electric or a magnetic field physically really is. We just know that
they don't know what the thing moving through it is. They don't know where the photons live. They don't know where they're made. They don't know how they're made. They don't know how they don't even understand the idea that it's just energy trapped inside of matter. You know, that, you know, yes, they're so clueless, and yet they're so confident in this model, and it hasn't really produced anything if you really think about it. I mean, we're still using technologies that were around 150 years ago. We're still, you know, bound by what we discovered a long time ago, and they haven't enhanced the understanding at all. As Einstein said 2 years before he died, I mean, he spent 50 years thinking about photons, and he hadn't improved his understanding one iota. They really don't have an improved understanding of any of this.
they exist. We know how to measure these things, but we don't know what they are, say, classically, or how they propagate. But really, we can't say much about what those things are. So that, I believe, is just a really very big problem. I mean, fundamentally, most of the time, magnetic and electric fields must be created in the presence of real charges. So in the case of magnetic fields...
So again, this idea that a field has to be created in real charges, you have no evidence for that either. That's, again, just more of their... Well, we'll say that's... We'll connect the two things because they seem like they're connected somehow. Electricity has something to do with electrons and sort of kind of moving, but it's more like drifting, and you know, they're actually moving slower when electricity's going through the wire. You know, it doesn't make any sense to this association between this idea of a moving charge when no, what's really happening is you're actually charging something. That's what induction is. You're taking a compression here of an atom, let's say pressure, and you're conveying the pressure to something else and causing the same effect that pressure caused in the other thing. So it's kind of obvious that's what's taking place. There's no need to do this connecting moving charges with something. The movement is very specific. It creates a very specific condition like polarization. That's what the movement is causing. And it's the polarization that's creating the phenomenon, not the movement. The movement is necessary to the creation of the polarization, but it's the polarization that's creating charge.
Fields, you must have charges and motions, like some kind of electron in motion. And in order to have an actual electric field, you need to have a charge present, like, say, an electron or a proton. Something has to have a charge to emit the field. But
so again, understanding that the charge of an atom is a consequence of the disposition of all the elements of the atom. So it's not the electron or the proton that makes it. It's the arrangement of those things. And when you change the arrangement, you change what it radiates to the world, how it looks to the world. You know, just as if I put this in front of me, if I put it closer to you, I disappear. Farther away, I exist again. You know, what I look like is completely dependent on how I'm associated with other things.
In the case of the electromagnetic wave, we are to believe that we have this self-propagating electric field, and this, if you notice, this electric field and this magnetic field rise and fall at exactly the same time.
Well, it's stupid to call it a self-whatever. The field is obviously dead, and it just sits around waiting for something to disturb it. So the theory they have, or the argument for this ether stuff, is that something has to agitate the system. So in my opinion, that's no different than me saying, you know, your first event has to be a bunch of agitation, a bunch of movement, stuff already in process. You have to put a wave in the space somewhere and say, there's something waving, which isn't any different than recognizing that maybe there's stuff that's moving perpetually and stuff that isn't. There's matter and there's energy. Two different forms of two different kinds of things, and they interact. Not with each other, but through each other. They interact not with themselves, but through energy affects matter, matter affects energy. They don't, matter doesn't do matter, and energy doesn't do energy.
Maximum, and then they completely die out to zero, and then somehow magically, after it's dead and it's zero, it magically resurrects itself, goes to a maximum, and then goes back to zero again.
Well, obviously the zero just has to do with a neutral point of where it started in terms of running a circle. So you really wouldn't say if something's going a starting line here that you just arbitrarily declare go, and then it runs around the track and it hits go again. You're not saying, oh, it stopped moving. You're just saying it's passing go again. So I think that's sort of a false argument. Obviously the momentum would still be in the system as it passes through what would be an arbitrary 0 point, an arbitrary ground.
Which just seems extremely unlikely how we could do that. So we discussed a bit about...
Well, obviously it couldn't do it unless you have something connected, like a rope. So you can put a wave into a rope and it has lots of 0 points, but the 0 points don't mean there's no energy in the rope. It means it's in the process of moving in a direction. It's in the process of going from down to up. So it has all kinds of momentum in it. And the key thing is it has that momentum because all the rope molecules are tied to each other. So they drag each other along. And so your ether has to be full of stuff that's connected to each other. And as soon as you make it gluey ether, then you got to explain it's going to have insane amounts of drag. So where's the drag?
You know, the derivation of the electromagnetic wave and how that didn't really make any sense. But I realized that, you know, anyone else watching this will probably say, hey, there's like, you know, several hundred years worth of evidence to support this, and every experiment agrees with this, and everyone thinks that this is exactly the way it works.
So again, there's nothing. There's all there is Maxwell's equations, and again, Maxwell's equations can probably be reformulated by somebody with a little bit of mathematical talent, and with the assumption that there is no distinction between E and B fields. So just get rid of the two concepts and just change the constants into the speed of light instead of having two separate mu0 and mu and epsilon 0. And just recognize that monopole charges have you know, a different a different ability to affect a distance than dipoles, which become weaker at distance.
And so, yeah, so there may be some other evidence, and maybe I'm just being a bit naive, but I'm not going to try and address, you know, all of that, all the possible evidence there is in favor of this picture.
Well, I mean, you could address, the point is you can't find any. So you know, and even the evidence that you think exists for the theory, I don't think it is evidence for the theory. So the two things you're going to mention, polarization and the photoelectric effect, in my opinion, have nothing to do with this nonsense either. They're not defenses of this silly interpretation of reality. Rather,
I'm just going to basically start fresh. If I were to look at this without any knowledge of, any previous knowledge of how people think the electromagnetic wave works.
Right. So if you just went from the premise of, well, what does the evidence demonstrate? What do the experiments say? They say energy lands in quanta, that it has photons appear to be identical and of the same force capacity, separate from the point of frequency, which is, volume. So if you change their volume by having more in the same amount of time, obviously you've made the impact greater, but it can be understood that the quantized nature of it is still intact. And that light doesn't degrade over distance. It doesn't do a lot of things. So clearly, we can know a lot from the experiments that exist. But none of them are evidence of any magnetic field or electric field having anything to do with it beyond the fact that photons are created by disturbances in atoms, disturbances associated with the electrons. But that's it. The only connection to anything electrical is the fact that electrons produce the photons. But that's it.
So going back to basics, we think that light and radio waves are a wave phenomenon because they appear to obey basically all the same laws as sound waves. And for example, Ian's paper last week basically showed that that was fairly true, that there aren't any other
wave is a wave is a wave is a wave. So again, but none of these things are waves. So even sound waves aren't waves in the sense of the way people are thinking about them being some kind of something other than an emergent phenomenon. There's an underlying mechanism that creates waves. Waves aren't fundamental. They're not elemental. They're not something isn't just a wavicle. There's no such thing as something just waves. Waves are a byproduct of something that's not waving.
Anomalies in electromagnetic wave would indicate that it doesn't follow the laws of sound. And for example, the ability to form an interference pattern is another strong piece of evidence that.
So again, that's where I'd say, well, you're using an empty sleeve kind of, that's just an empty bag kind of piece of evidence, because all of this interference nonsense doesn't really exist as anything meaningful. The kind of effect you have with mechanical waves like water waves, it's on, off. It's up, down, up, down, up, down. It's agitation versus no agitation. It isn't photon, no photon. It's quite different in terms of the effect. The photons don't hit with twice as much frequency. There's not some similar distortion of the reality. And so the mechanisms are not the same. The byproduct, the outcomes aren't even that similar. Clearly the mechanisms aren't similar. I mean, one is traveling through an actual medium where it's actually is things like friction and drag are real, and the other isn't, clearly.
What we're dealing with is a wave, because waves have the ability to cancel and to reinforce, and we see that in.
So there's no canceling of a wave. There's particles that have a different trajectory, and they cancel each other's motion. So if two come out this way, it cancels in the sense that this way and this way will be lost, and the thing you'll end up with is this way. So that's all that's happening. That's the wave mechanic. There's no canceling out. There's just two different forces interacting and nullifying each other. And that's what particles do.
The generation of interference patterns. And specifically, EM waves have a measurable frequency and a wavelength.
The same difference. So again, it's just silly. Obviously, yes, and the wavelength is exactly proportional to the frequency and exactly proportional to the period. So let's have three ways of describing, or maybe there's four, exactly the same thing. How tall is it?
And probably an amplitude and a wavelength.
So there's no amplitude. So photons do not have amplitude. They only have amplitude by the volume of the photons you create. So there is no amplitude in the wavelength.
For things which we can physically measure, they obey the same kinds of things like Doppler formulas for approaching a receding sound wave. And really, most every experiment you could come up with, except for
So they do mathematically claim that sound and Doppler effect is different than with electromagnetic radiation. So they make the claim. I've asked for one experiment that shows this difference, and I haven't been able to find any. Some example of how sound cares, whether it's the emitter or the receiver, in terms of the amount of shift there is. And there's no evidence of this.
Very few exceptions show that light waves behave exactly the same as sound waves. But instead of thinking that...
So again, they don't obviously behave exactly the same way. I would confine that statement to say there's no evidence of an electromagnetic field having anything to do with it. So, but they're obviously not the same in the sense that the sound waves are traveling through a medium that has adhesion, and photons don't appear to be doing anything like that. You can't slow them down, you can't create friction, you can't do all that kind of garbage.
The electromagnetic... Just a moment. But instead of thinking that the electromagnetic wave is exactly like a sound wave, we instead think of it as this extremely complex blend of electric and magnetic fields.
Those shouldn't be the two choices. Sound, it's exactly like a sound wave, or it's a convoluted pile of crap about something doing this and then snake motions in two directions and all that kind of crap. Yeah, that's crap. But it's also crap to say sound and light are the same phenomenon, because they're not.
So, but I would say that this is wrong. As much as everyone thinks it's right, I'm going to go against the crowd and say that that is, in fact, completely wrong. And go back to the old hypothesis that the EM wave is exactly the same thing in nature as a sound wave.
So he keeps saying the old. No, it's not necessarily. I mean, it depends on how far back you're going to go, and then I don't even think they had a way of knowing that light was a wave. So, you know, Huygens made light, was the one that started it, so to speak. I don't know if anybody who before that was speculating about wave of light when it looked very ray-y.
And that means that the EM wave travels as a simple compression wave in a particulate medium. So we think we completely understand how a sound wave travels. And
so anyway, again, so the particulate medium again comes up, and again, I would argue that the motion required for your particulate medium, that is the motion of your neutrons to bang into each other to collect into little groups, you know, you have two here, it bangs in, now you have two here, that bangs into this one, now you have two over here, that bangs into this one, now you have two over here. This is moving, so why not just get rid of this and just have the moving bit? Have the neutron make the whole trip and then call it a photon instead of a neutron. I mean, why bother with the medium? It doesn't do anything. It doesn't serve any purpose. It doesn't have a function.
So it would be the advantage that if we can think of it as exactly the same thing as how sound travels, then I think we could say we would know exactly how.
So understood. Sound travels because molecules do exactly what I just said. Atoms bang into each other and are close, and then that closeness is spread to another set. This one leaves and creates closeness with a new one, and then it creates closeness with a new one, and then a new one, and a new one. So it moves through the distance between the atoms, and that's all. But I mean, that's, you know, there is no correlation to any notion that there's any such field of atoms. And we know that sound is, you know, it's not precise. You can't send a little sound beam, a laser beam, you can't send it in a nice straight line. So the atoms are misaligned, and so their sound goes in all kinds of directions, and it's kind of sloppy, and it doesn't even make very good interference patterns.
Electromagnetic wave travels. And really the only thing that is happening when a wave travels through space, like a light wave, is that there's
So again, he just, you know, so he's not too comfortable with their assumptions about what they're calling electromagnetic, but he accepts this idea of waveness, and I don't know why that appeals to him when, in my opinion, there's just nothing about photons that appear to be waving anywhere. They seem to move in very straight lines. and stuff doesn't go through mediums in straight lines. We're back to the checkerboard problem. If I make a checkerboard, the problem is that the distances aren't even. You know, this way and this way are shorter than this way. It doesn't come out the same. You know, we hit 3 spaces going this way, you hit 3 spaces going this way, and it's a longer distance. So mediums would have to have some reveal of the fact that it's different speed going one way than it is going the other way. Each direction would have to have a variability about it, and that's not what you see in light.
Medium that's being alternately compressed and rarefied, and nothing more than that.
So again, compressed and reified. So again, that's all this means is again, it's just things banging into each other, and then, okay, there's 2 things close to each other, 2 things further apart, 2 things close, 2 things further apart. That's all. They're things, not waves.
People try to make this more complicated, but I'm just putting up this hypothesis that it's an electromagnetic wave is nothing more than a compression and rarefication of a medium, of an elastic medium, which is exactly the same as what we think sound is. For example, it would be...
So I would argue that I would concede the evidence is bad for both, but yeah, you know, I don't think they understand sound, and they clearly don't understand light or radio or any of the electromagnetic spectrum. So the incompleteness of their theory is glaring in terms of it doesn't reveal any deep understanding of mechanism.
Ridiculous to say that a sound wave is traveling with a electric and magnetic component, and it would be inconceivable that these two...
I don't know if it would be ridiculous, any more ridiculous than what they've theorized about light. So I'm just saying that's clearly what they could do to you. Instead of you making making light into sound, they could probably make sound into light. And they could create 2 idiotic fields and come up with a permeability and a epsilon 0 variables, and they could come up with all this crap and make it more complicated than it is. They could do that. Okay, now I guess the default was already simple enough that they didn't need to, but the truth is they could do exactly what you're doing in reverse and just turn sound into electromagnetic, or just call it something else. Just call it molecular stickiosity, you know. So it has this molecular stickiosity field, and it's permuslopinosities field or something. You know, they could do the same thing.
2 components can somehow travel at a 90-degree angle to each other. You know, it just makes no conceivable sense I gotta change my thing here. Makes no conceivable sense that we could possibly describe a sound wave in the same manner that we describe electromagnetic waves.
Well, you say, I'm just saying, why not? Why can't they do it? It doesn't make any sense for one, and why would it make it? Of course, it doesn't make any sense for sound either. It's not going to be at all intuitive or reasonable by any obvious mechanism, but I'm sure they could do it. So challenge them, and I'm sure they can do it. Challenge them to come up with a bunch of Maxwellian bullshit for sound, and they can do it. They can create mathematics that splits an entity in half, and that's all they've done. They split one force into 2 forces. That's all they did. They can certainly split the speed of sound into 2 forces.
So, the other thing is that in spite of the name electromagnetic wave, I don't think that the EM wave actually has anything to do with the magnetic or electric field. Those things exist.
Yes, well, there's obviously no evidence that you can detect the disturbance that they are in the field at all. Can't detect it. You can't change their path by influencing the field. So it doesn't matter how much magnetism I throw at a photon. It's just not going to change its direction at all. So clearly, yeah, there's no evidence that it's electromagnetic. If there's any evidence of anything, it's gravitotic or something, gravitotic. But again, I would argue that's no good. That evidence sucks also. So they've assumed it to be bendable by gravity, which it's not. And it clearly doesn't, isn't influenced at all by anything called a magnetic field or a charge field. So whether it's a charge field, monopoles, or whether it's dipole magnetism, it is not affected by it.
Exist, but just like that doesn't have anything to do with sound traveling through air, I don't think that has anything to do with the electromagnetic wave traveling through space.
Yeah, well, I don't think it's a wave, and so I think you're just wasting your time with that word. Again, wave is emergent. Wave isn't elemental. So if you're going to do physics, you got to get to the elemental. Waves aren't elemental.
So, as I said, if it did have anything to do with electromagnetism, I think we would have been able to trivially measure them. But we can't. And if you try and produce an electromagnetic wave by, say, using a time-varying electric field, that doesn't produce a long-propagating electromagnetic wave.
Sure it does. So if you could vibrate a field at nanometer wavelengths, you could create light that way. But we can't do that. So that's why we can't make light. But I mean, that's all it is. It's the same stuff. It's just a different frequency. So I think you're a little bit wrong-headed to think that light is somehow specifically different. It's not in any specific way different. It's just that we don't have an atomic mechanism other than exciting electrons to produce it. There's no other way to do it. You can't synthesize it through some other mechanism.
Similarly, if you try and produce a time-varying oscillating magnetic field, that doesn't create a long-propagating EM wave either.
None of them are long propagating in any sense beyond the fact that the individual photons are forever propagating. And there's every evidence that magnetism is doing exactly the same thing. So you're saying that it's not long propagating. Of course it is. The force goes forever. It's just that it's diverging and spreading with distance, and it's diminishing and diminishing. And obviously, to have an effect, you have to be kind of close. So you're just basically, look, I could put, dark shields in front of my eyes, so only the most intense light possible I could see. And so then everything would have to be really close for me to see it. But that doesn't mean that photons a ton of them aren't going past me and I'm just not seeing them. So, I mean, I don't think that was a very good argument. I mean, the propagation strength, all of these forces have the same durability over distance, sound included. Sound is not like supersonic or something. It's just that it's made out of molecules moving, all right, and it does create heat. It does, it has a lot more friction, so it's diminishing by more than the inverse square law.
That can travel long distances. These things were tried in the early days of radio, and it just doesn't work. For example, if you do this with the magnetic waves, you can in fact create a magnetic wave that doesn't travel very far. And
so that's just nonsense. They all have the same rules about how far they travel, and the point is if you're shooting a diluted, dipole field, that is, you have more red coming out of this side, more black out of this side. Well, obviously at a distance, that's going to become one thing. So at a distance, it's going to lose the difference between one side and the other side, and the two sides are going to end up blending. So the force felt is not going to be the same. But the actual things, the rays, are exactly the same. The same amount of rays came off of it. The force is still there. Again, like the radar two-slit experiment, the force is still there. You just can't tune it in. There is nothing got killed. Nothing died. There was no photon plus photon equals no photon. There is a photon. You just can't tune it in.
You can recover the energy. This is how you can wirelessly transmit significant amounts of power.
You can't wirelessly transmit significant amounts of power, so that's just nonsense. You can't do that. I don't know why you think you can do that. There's no successful transmitting massive amounts of power anywhere without insane amounts of loss. So yes, if you're willing to throw away efficiency, you can transmit electricity, but you can't do it for any distance. So I don't know why you think that. That's sort of a gap in your understanding.
Air by using a time-varying magnetic field, but you don't get radio wave out of these things. So you would think that if the
all right, so this is kind of a false argument. He thinks that somehow sound travels with impunity, like some sort of special, it doesn't degrade, it doesn't diminish, it doesn't diverge, it doesn't get weaker with distance. When it's doing the same thing that the EMF waves are doing, it's diminishing, and it's really just about volume. Sounds are a lot of molecular motion, especially big sounds. They're all little sonic booms after all, too, as I pointed out. But it doesn't obey any. There's no special rules for sound waves. There's no special rules for sound compressions. They degrade because they are, in a sense, particulate. Atom has to hit atom, has to hit atom, has to hit atom.
Yeah, electromagnetic field, we're really this time-varying electromagnetic thing. You'd think we'd be able to generate them with time-varying magnetic and electric fields, but that just doesn't work.
So again, that doesn't even make sense, because obviously exactly how we create them. That's exactly how a radio wave is created. So, that just doesn't make much sense. Detecting, we should be able to detect them. If they're moving through an actual field and they've disturbed the field, we should be able to send energy into the field and reveal their shadow, so to speak.
Well, that's yet another piece of evidence that these electromagnetic fields don't have anything to do with the propagation of things that we recognize.
They don't exist. That's what your statement should be. It's not that they don't have anything to do. They don't exist. The fields don't exist. Fields exist when there's force. So when you have stuff, then you have a field of stuff. But without the stuff, there's no field.
Nice as a light wave. So I would...
And again, it's a light photon and it's a light ray, more than it's anything called a wave. It behaves like a ray, it behaves like a corpuscle. This wave thing is just such a distraction from the truth.
Think that if the electromagnetic wave is in fact a wave, then the only thing it can be is a compression wave in a particulate medium, just like sound.
So, and again, a compression wave is talking not about the element, it's talking about the emergent. The compression is made out of things getting close to each other, more mass in a volume, more stuff in a volume. That's a wave. That's a compression. It's actual stuff, though. The stuff is doing the moving. Something is moving, not a wave. Stuff is moving. I mean, wave is just such a sloppy word. It's not elemental. It should be banned from physics because it's not elemental.
None of this transverse wave stuff, none of this time-varying electric field stuff, none of this magnetic field stuff.
Well, time varying is obviously frequency, so that stuff matters because we obviously know this stuff has a frequency. So it's silly to say, let's talk about sound without any time varying. Of course, the frequency is everything to the sound. So without the frequency, it's an interesting perturbation, but it doesn't contain any. It doesn't have any utility in a lot of ways. I mean, it's beyond like a blowhorn or something.
All it is a simple compression wave.
Again, a compression wave is not simple. It's something. It's made of something, and that's what people ought to be talking about, is what is it made out of, and how does the stuff it's made out of create the illusion, the perception of a waviness.
So, what are the problems with this idea? So, since pretty much most of the experiments agree that the EM wave is a simple compression wave like sound, then what are the problems that prevent it?
No, most of the experiments indicate that it's just stuff at a frequency, clumps of stuff at a frequency. That's what most of the experiments indicate. Clumps of stuff at a frequency. No wave.
From adopting this simple conception. Now, the first obvious problem is figuring out what this medium is. And so for sound waves, we have air molecules, and we understand that very well.
Well, we have all kinds of molecules. Sound travels through water, it travels through glass, it travels through steel, travels through a lot of stuff, and it travels at a different speed and all of those things, which is sort of an indication that we can sort of deduce that the difference between those other denser materials is the fact that the atoms are closer to each other, and that's the only difference. In the gas, they're further apart. And so that's a key ingredient to the speed of the perturbation, is overcoming the fact that the atoms must move into each other. And if we give the movement of the atoms a certain limit to their acceleration, that is, they can only be accelerated so quickly, then there can be a consistency in the sense that this speed is always the same, and all you're really changing is the amount of distance between the atoms and the time it takes for the perturbation to motivate the next atom to move. So again, they're banging off of each other's electrons. So it's really, you're just talking about the compression speed of electrons. So the more electrons you hit is inversely related to the speed, because the electrons move faster than the atom moves traveling distance. So the more atoms, the faster you'll go, because the more atoms means the more electron interactions and the less moving across space. The more space you have to cover, empty space, the slower the wave in sound. Let's see if this will work.
But what does the EM wave travel through? We find that EM waves travel through perfect vacuums, which don't look like they contain anything at all. So how can an EM wave be like a sound wave if there isn't any particulate medium to travel through?
So again,
so that would seem to be a problem. I mean,
So again, these ether people are just so glued to their perception that they can't even imagine. I don't know why they can't imagine it, but they just can't imagine a universe that's made out of asteroids and comets and moons and planets and round things hitting each other, and they somehow have to turn everything into some sort of, perturbating stuff. I mean, there's just no need for it. You just don't gain anything, again, by compressing a medium when you can just have the thing travel the distance. Why bother with all these little movements when you can just solve the problem by just having this thing move from here to there at a certain speed?
This is the problem. It makes people think that light is actually, quote-unquote, a photon, which is literally like a matter particle. So if you have a matter particle, that can travel through absolutely empty space, no problem. It doesn't need a medium, but then it wouldn't be a wave. But what I'm talking about is that that light, as it travels, is actually traveling as a wave, like sound.
Right. You're saying it's traveling through a medium. So again, so he does believe in ether, and he's saying basically that the ether is going to be made out of neutrons, which in my opinion is just a non-starter. It's matter. It's gravitational. It just wouldn't make any sense to me at all.
And that really requires physical medium. Now, this isn't actually such a crazy idea.
So again, he says it requires a physical medium. It doesn't require it. Bullets don't need a medium. They say, screw mediums, they're my way. They got no use for the medium.
In that, in the past, prior to Einstein, it was actually commonly accepted that there was this invisible medium that people would refer to as the ether, and it was commonly thought that EM waves were really just like a sound wave, since the vast majority of experiments conducted up to that time agreed with that hypothesis. So
I don't agree with that at all. Obviously, Newton didn't think so. I don't think there was any consensus that it's people thought of, they were just so convinced, overwhelmed by what evidence. Again, you're talking about at a point when they didn't even know that light had a frequency. So to say they were thinking in terms of waves, I just think is bullshit.
Now, this isn't some crazy crackpot idea. A lot of people used to think that's actually how it worked. But the question still remains about, what is the ether and why haven't we detected it? I mean, that's a pretty big problem. If we say there's some material ether out there, but no one's been able to detect it, well, easy to see why people wouldn't believe you.
I guess it's the hairy guy who has his mic open. Obnoxious, rude shithead.
So, but fundamentally, if we were to claim that the EM wave is a sound wave, then it needs to be made out of tangible matter, like oxygen and nitrogen molecules, that can be compressed. but we don't see any tangible matter in a vacuum.
So again, compressed is a tricky word. The compression just means that they bang into each other. They become clumpy, you know, two, and then the two-ness is spread. Two, you know. It's, you know. The wave is not elemental. I'll just keep saying that over and over. Waves are not elemental, and they really shouldn't be something physics. The term should never be used in physics as if it is elemental.
So this is a paradox. But no matter what it is, in practice, any particulate physical medium would do the trick. So
okay, I would say obviously not any, because the trick it's doing has to fit all kinds of circumstances where you don't have spreading, where you don't have this checkerboard problem of the diagonals being longer distances, where, you know, all this stuff that you have to account for. I mean, if it's perturbations and each perturbation is a connection between dominoes, obviously the diagonal dominoes flip at the same speed, but they travel more distance.
I'm going to propose a particular possibility candidate for what this ether is. So to fit the bill of a for the EM wave, it has to be made out of ordinary matter. You know, nothing exotic. It has to be made of things that we currently recognize, but yet be completely undetectable. Now, when Dirac must stop that, there might be a sea of electrons. Oh, no, just heard all that coughing. You might want to mute yourself.
Yeah, you might want to mute him, and you might want to just say, you know, Jesus, you got your microphone open. It's supposed to be let me do my thing. Why are you coughing on my fucking show, fuckhead?
But I think, for example, the charge would easily give that away. So we would want something that really doesn't have a charge, should be neutrally charged. So the simplest particle that we know about, which is neutrally charged, would be the neutron.
So again, you know about it. I don't know about it, okay? That it's neutrally charged in any sense that it doesn't have charge, and that it's not made out of a proton and an electron, which it appears that it decays into. So, I mean, you already have knowledge that maybe this neutrality thing is a consequence of having both plus and minus. It's a dipole, essentially, that's spinning. So why do we have to make it more, you know, why are you pretending you think you know what the word neutral means?
So suppose we run with that. So we fill all of space with a sea of neutrons.
See, I don't think there was any point in him doing this part of it, okay? So where he's trying to theorize what his ether is made out of, because this is just a distraction from the point that there's no electromagnetic field, that hasn't been proven or demonstrated with any preponderance of evidence. No volume of evidence indicates there's any such thing. And if you really start dissecting it, especially through Maxwell's equations, you can sort of see that there's this unnecessary division of the mathematics into two separate B and E fields as if they're fundamentally different, when no, they're basically just one's a dipole field and one's a monopole field. What's so complicated? Problem solved.
Since neutrons have no charge, they interact very, very little with ordinary matter. Neutrons, if you didn't know, can easily pass through a great deal of matter without being stopped. I mean, I could shoot a beam of neutrons at you. They would go through you, through your house, and through your neighbor's house.
It says you. That's neutrinos or something. You know, if neutrons were that benign, we couldn't. The atomic bomb wouldn't work. Clearly, they're not that benign. But yes, they're big. So you can shoot them through stuff, and they'll tear right through it if you give them enough momentum, okay? Because they're big. They got a proton and an electron. Give them any kind of momentum at all, that's a big bullet, and they just rip through anything. So ripping through something is a lot different than benignly traveling through it. So I think you'd be hard-pressed to demonstrate that you can shoot a bunch of neutrons through somebody without screwing them up.
They interact very little with matter. I think you actually have to have several feet of lead to actually even slow them down. So the question is if...
so I don't buy that at all. I haven't seen any neutrons in cloud chambers and whatever, so I just... No, sorry, no sale. Helium nuclei, maybe, but not neutrons.
If we were surrounded by a sea of neutrons, would we necessarily know it? I would I don't think so, because the interaction with ordinary matter would be so little.
So again, it does interact intensely with ordinary matter. So again, a wrong assumption. Clearly, the neutrons are essential to holding the nucleus together. Clearly, they're interacting with the protons in a profoundly significant way, in the sense that now we're able to take two things that are hostile to each other and put them right next to each other, and the neutron is the obvious glue for that process. So to say they don't interact with regular matter is just bullshit.
That if you had a jar filled with neutrons, it would in fact look like a jar with a complete vacuum. There would be no practical way to create a material that could physically hold neutrons in it.
All right, so again, and then we have this idea that neutron stars are very dense, turn into black holes, all this kind of stuff. So clearly the density of the neutrons, the fact that they're creating a gravitational pull, would indicate they're having a huge interaction with regular matter again. So gigantic interaction with regular matter, in the sense that they will create a gravitational field, a gravitational influence, and pull regular matter right to them. So wrong again.
As I said, they flow through everything, much like water through a net. So any container that you could possibly build would likely have exactly the same pressure on both sides of the barrier. And because
just again, more nonsense. If you take neutrons and collect them in an area, that you're going to have more mass per volume, more density of mass, and therefore more gravity.
Therefore, not detect any pressure differences like we would if there were air molecules in the container. I would contend that a sea of neutrons would be very, very, almost impossible, possibly hard to detect. And there are...
All right, so you'd have to prove that. You have to prove that neutrons are number one, hard to detect, number two, that they don't have a gravitational influence, and number three, that you can give them momentum and yet you can't detect them. That doesn't even make sense. How do you shoot these neutrons at somebody if you can't control them? Doesn't even make sense, does it? Does it make sense on its face to say, if I shoot a bunch of neutrons through you, well, how are you going to shoot them through me if you can't get them to interact with regular matter?
There are other reasons to think that what we consider a vacuum is really completely full of material particles. And if you listen to the mainstream, they will often refer to things as virtual particles.
So again, I just think that you're just stepping right into a huge problem once you make your ether into a gravitational field, because I don't see any evidence that it doesn't make any sense, in the sense that your ether has to, what's it, how volumeless is it that it doesn't have a gravitational influence? How can it be made out of matter and not be gravitational?
And quantum phones, but all of these things really point to a material substance existing in what we call a vacuum. There are also other significant experiments, such as the lamp shift experiment, which basically say that the only way that they can
I don't know what the lampshade experiment is, so yeah, I couldn't tell what he said. But I'm sure there's lots of wacky experiments out there. They think they've proved entanglement. They think they've proved a lot of things. And the experiments are incredibly convoluted and complex. So if you want to say there's an experiment out there that's decisive or something, I'm going to say probably that's rubbish, because they still haven't fessed up to the fact that the Eddington experiment's garbage.
Figure out this shift happening. Is if space were just filled with the sea of positrons and electrons? So I would take that just one step further and contend that the neutron is really a combined positron-electron dipole particle. And I have...
So positron dipole, well, positron is already a mini neutron. I mean, already a proton, just a smaller, lighter version, proton 1. So, yeah, it's obviously a mixed charge. So then you're conceding that the neutron isn't neutral, that it's a dipole.
Of this particle, the positronic, to separate it from what we normally call a neutron, which is something which is typically found in the bound atomic nucleus. So I believe it takes on a different physical characteristic as...
Yeah, well, you're just making this stuff up, and that's fine. We all have to make up something as a structure, and you're using this, but I think you're just stepping into so many questions you're going to have to answer about how you put matter in the ether. So you give the ether a material element, then you're going to walk right into all the drag issues and all the gravity issues and all the friction issues and all the crap that comes with that. So I'm just saying you're stepping in I think it will provide, you'll never escape the problems you're going to create by having a material ether.
A positronic. So, and I would contend that this positronic would be a completely stable, neutrally charged, ordinary matter particle. It would have a measurable mass to it. being composed.
Then it's creating a measurable gravity, and then it's going to have to interact with regular matter, whether it likes it or not, because it's going to be attracting regular matter.
Of a positron and an electron. So I would propose that this precisely defines the nature of the neutron in terms of ordinary particles, matter particles, nothing exotic.
Right, and these whatever you called it, this fake neutron that's supposed to be neutral, will somehow have to be interactive in the sense that you can somehow compress it and it will rarefy, because you have no wave without the action causes reaction. So if the compression doesn't create an expansion, you got nothing. So you're going to have to explain the mechanism of their repulsiveness or their attractiveness or whatever force effect. So now you're back to the force again. So you might as well just start with a force. There's just no point in pretending that you can do physics without recognizing that a force has to be something smaller than the matter.
Which we currently think of as fundamental, which is just the electron and a positron. I mean, so far, that's the only easily found particle for which we cannot find any.
Again, the positron is just just their guess, okay, based on the fact that something that would look just like an electron is going the wrong way, so therefore it's positively charged. So again, but we can't tell whether it's a proton or not. A slow-moving proton is the same thing. It looks the same as a fast-moving electron. There's no distinctions. So again, this is just more speculation based on a little bit of evidence, and the evidence just isn't clear enough. Gives you a little bit of an indication, and you just keep saying we have to choose left or right, and we're going to commit to something, and then we have build a whole story of commitment based on that ancestry. And no, maybe you should have married the other girl.
Evidence of it being composed of anything. So far, most of the experiments would say that that is fundamental. So this solves one of the major problems with the EM wave by defining the particulate medium that is both.
I'm sorry. So yes, getting rid of this EM crap, this electromagnetism thing that's never been demonstrated to exist, is one project. Replacing, saying that somehow it's necessary to contrive this nonsense about a material ether is not, in my opinion, it's just as bad as their sloppy guesswork at electromagnetic causes for photonic radiation. This is just as bad a guess, in my opinion, as that bad guess.
Made out of ordinary matter particles, but it is generally completely invisible. So that solves the big problem of if it's over.
Matter can't be invisible, so unless you want to call it dark matter or something, you want to give it some sort of silly properties where it has all the properties. Now it's exactly opposite of dark matter. It has all the properties of matter except it doesn't cause gravity. So now you're just creating some new form of matter that breaks the rules.
Then what is it waving in? So it's waving in this neutron sea.
So again, waving in is the whole problem. Why create a medium when you don't need one? you have something behaving just like bullets traveling a distance, and you're sitting here forcing there to be a wave, forcing that to be a wave, when it just doesn't have to be forced into that. It doesn't have to be forced into being a wave.
Just can't notice because neutrons slip through everything. There's no charge.
As you just pointed out, it's made of charged elements. You called it material. It has gravity. This is just, sorry. This part is stupid.
And there's no way we can contain the neutron sea. So this is why it looks invisible, even though it is quite possibly the densest substance in the universe, really.
Right. So again, but these words don't mean anything. Density doesn't mean anything if density isn't going to be associated with the functions of density, with the number one function, which is it causes gravity. So again, you're just going to have to make up an invisible man matter that doesn't. Okay, it's just like matter, except it doesn't cause gravity. Bullshit.
So now that we've solved that problem, so what are the other experiments that contradict the idea that the electromagnetic wave is like a sound wave? So I would say there are really only two experiments that contradict this view.
And I don't think they do. So these two experiments demonstrate, in my opinion, They're evidence for the superfluousness of this electromagnetic field, not evidence against.
So every other experiment says EM light is a wave. And then we have these two experiments that contradict.
So again, it's just all the experiments point to light being a wave. No way. It's just a crazy statement. Just crazy. You know, in terms of my own experience with light and the way it bangs off of stuff. It doesn't spread. It doesn't do anything like waves, photons. They really are nothing like a wave in common experience.
So the biggest one that people bring up is the transverse wave conundrum. And this has to do with polarization. So the simple argument goes that since light waves can be polarized and sound waves cannot, then EM wave must be something completely different from sound waves.
Yeah, we already know they're completely different, okay? One's big giant molecules banging into each other, okay, which still has to do with the pressure of electrons, you know, and stuff. But it is so inarticulate. It's on such a big giant, you know, galaxy against galaxy scale versus comet against moon scale. They're two different scales of interaction, and the interactions are completely different because of that. The difference in the density and the hardness of the objects and all of that crap. So clearly the photons are much more elemental than these big giant molecules banging into each other.
And especially since it's polarized, that they're saying that if you go back to this original picture here, that it's picking up the transverse components. This is often shown kind of like a rope going through a picket.
And clearly, the reason why the reason why sound isn't polarized is because sound is it's actually pushing molecules, okay, off of a surface, and the frequency has to do with pushing them. So there can't be any polarization. There's no ray of sound. You know, it's just not a ray of something emanating from one location. They're all new molecules being pushed. It's not like a energy coming out of an electron. You know, it's so different.
And so only the waves which fit through the slot are allowed to progress. And then they try and apply it to this picture, which you see if you apply this picture through a picket fence, it would basically filter out the magnetic component here. And then that would completely tear this thing apart. So you would predict that if you put this wave through a polarizing filter that worked like a picket fence, this would destroy the electromagnetic wave completely, filtering out, you know, at least the magnetic component completely.
It does seem contradictory, so I don't even know why you're using this argument of even talking about polarization, because obviously their vision of this two-direction thing doesn't go through filters very well. So yes, how can you make the photon different and the photon is still the same? That doesn't make any sense. So you can't be stripping half of its identity off of it and say, oh, it's the same photon. Well, it's obviously not going to be the same photon. Anything close to the same photon, yet behaves as if it's exactly the same photon, so how could it be a different photon? So yes, their theory is nonsense. It's rubbish. It's silly. So why don't you just say polarization doesn't demonstrate EM-ness at all? It does exactly the opposite. It demonstrates how that model of the photon as having two perpendicularly focused agitations, a frisbee flying both this way and this way. I mean, I take two frisbees and I cut a slit in them and make them into a frisbee this way and a frisbee this way. None of them go through the jail bars, obviously.
So if you think that the whole picket fence analogy makes any sense, well, think about it some more. You can see that it just doesn't make any sense. So let's go back and figure out really what's going on here.
So, you know, a 3-page paper, and you're going to try to cover the origins of the mechanism of ether, and then you're going to try to sit there and say, you know what polarization is. You know, I think you're taking this a little too, you're biting off more than you can chew here. So I don't think your theory of polarization is going to have anything to do with the reality.
So I think that this rather naive conclusion that light can be polarized, and therefore it's not like a sound wave, is throwing the baby out with the bathwater. Because I believe this can be explained. So the major difference between light and sound waves is really that light waves generally don't disperse or spread out from the source, while sound waves...
Okay, so of course they do. So even our best lasers disperse. So the rays are tend to not be able to be produced in the same exact direction, coherent, because the atoms and the electrons are always in different positions. They always have a different disposition. And it's very hard to somehow line up all the atoms identically so they all create parallel perturbations when you run a current through them. So they're all in the same exact position when they emanate a photon. It's really hard to arrange it that way. Maybe someday with crystals and different things they'll be able to figure out some way to do that. But there's a limit to it now, in the sense that you can never have that perfect alignment. And you need to be perfect. I mean, it has to be perfectly aligned to survive distance. Especially at the speed and that light moves. 1 second, 250,000 miles. Come on.
Always spread out pretty much. Because light waves do not disperse, they can travel as a quote-unquote ray, which travels like an arrow in a straight line.
Yes, the individual photons do that. The rays are dead straight, but you can't create a group of rays that are parallel. That's the problem. That's the limiting factor. Very hard to create parallel rays of light.
So this is actually, I would contend, the only property that light needs in order to be polarized. It doesn't need to have any transverse components, such as is seen in the conventional view of the EM wave. We can easily observe this property with a laser beam, which is a narrow, thin ray that doesn't disperse.
All right, so just, this is, everybody has their voids of their knowledge base, but clearly the lasers do disperse, and they disperse substantially, diverge. I use the word diverge, but dispersion. They spread, and even the best ones do it.
You can shoot a laser beam at the moon, and pretty much it maintains its shape and has some dispersion. But
no, it has a ton of. It goes from this big, right, to about on the surface of the moon maybe a kilometer. So it goes from this big to a mile.
Not really. The main evidence of non-dispersion is that we can see stars, which are billions of light years away. If light just all dispersed at all that would just turn into a fuzzy blur. But it didn't.
No, because we're getting the parallel beams are the only ones we're seeing. That's why it's so dim. Is the only light we're seeing are the ones that are coherent. That's it. That's the only ones we see. And they're coming from different locations on the star. That's why you see the whole star. You see a piece way over here, and you see a piece way over there, and a piece. You see little beams of light that happen to be all parallel because they came from different locations on the star.
Those light rays have to maintain their fidelity all the way across billions of light years to reach our eyeballs and still look like pinpoints. So
again, recognize this. They are still pinpoints, and we're not talking about pinpoints now. We're talking about the polarization is in the pinpoint. So you're trying to make polarization into a group phenomenon when polarization is an individual ray phenomenon. It's an individual point of light that has the polarization. So you're sort of talking the wrong subject here.
This really gives it some of the properties that we would normally only associate with a particle, in that it traveled as a finite-sized object through space. Literally.
Right. So that you're conceding that that's what the evidence indicates. So why are you creating this notion that everybody knows it's a wave when that's how it travels? It kind of obviously appears to be that way.
A little, like a pulse of light would be localized like a bullet or a pencil traveling through space.
So again, it's absolutely no need to turn it into a pencil and have another pencil jammed up against it, and another pencil, and then you end up with a photon that can be miles long, which is kind of a pencil miles long. That doesn't make much sense. So the simple solution is just to make it bullets separated by the distance, and the distance is the wavelength, the distance is the frequency, the distance is the period.
Which only occupies a fixed radius and a length. So if you were to think about how light travels,
so just forget about its length, but forget about everything about the photon except clump. It's clump. It's something, and it's something's at a distance, and the somethings are all identical. And the only thing you can change is how many somethings hit something in an amount of time. And if it's more somethings in the same amount of time, then we call it blue light. If it's less somethings, then it's red light. And if it's even less, then it's infrared light.
Literally traveling like a shooting arrow. It has a start, has an end, has a length, has a...
So again, it's not like a shooting arrow. It's like a row of bullets. Bang, 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 bang. 5 or 6 of them, 7 or 8, 10 or 12, who knows how many. But that's a ray of light, a beam of light. It's just made out of, it's produced by one atom, one electron moving, being vibrated in the tension of its atomic ties. So it's tied to the atom. The other electrons are repelling, the proton is attracting, it's in tension. You irritate it, the electron bounces in that irritation, and every time it bounces, it shoots a photon. And so you get 5 or 6 or 10 of them, and that's it from an electron that's perturbed. And depending on how aggressively you perturb it, will tell you how much you're going to get out.
Diameter, and it maintains that shape throughout its trajectory, just like a bullet. I think this is probably one of the confusions about, to say light is a wave and it's a particle. I say no. Light is a wave.
So again, he just pointed out how bullet works is a really good explanation, and then he says it's a wave. So why did he do that? I mean, what is that? Yes, it appears to be very pencil-like, arrow-like, bullet-like, ray-like, but I'm going to say it's a wave. Why? Why are you doing that?
But it's localized like a particle.
Which makes no sense. So, just you're complaining that they have a nonsensical notion, and then you say something just doesn't make any sense at all. A localized wave. It's just doing wave this way somehow. And then you end up with a field of dominoes or something. And again, you're back to the fact that the dominoes can't go in all directions the same way. You can't have, the field has to have a geometry to it. What's going to be your geometry? You can't have them evenly spaced without creating diagonal problems.
So it has some of the properties of a particle, but it's still a wave. And I'll get to exactly what that wave looks like in a little bit. But we're still looking at this whole question of how polarization works. So if light has this property that travels like a pencil, then we can easily explain polarization by looking at what polarization materials really are. So
this is, unfortunately, again, he goes kind of off the rails in the sense that this doesn't make much sense, because he's turning coherent light, beams of light, into light going all kinds of directions, when clearly it can't be going all kinds of directions. Light is predominantly going very consistently in the same direction. So you can't turn a laser beam into light going in all kinds of directions. That doesn't make any sense.
What polarizing materials really are there's typically a stacked crystal structure, which is essentially sheets of an opaque material with a gap between them, where things like light rays can...
Slits. It's a bunch of slits.
Can go between, but otherwise are blocked. So...
Not necessarily blocked, but transmitted differently. So you got to be tricky. There's no blocked technically, right? There's absorption and readmission as heat or something else. There's some other form of radiation. You can convert energy into another form of energy, electromagnetic energy into another form of electromagnetic radiation that's invisible. But there is no blocked.
This is a little bit like stacking boards on top of each other, leaving a gap between them. So if we think of this stack of boards and we try to fire pencils at...
So again, jail bars I think works just so fine, picket fence, whatever. I mean, jail bars works, just,
At random directions, we can see that only pencils that are going to get through are the ones that happen to be exactly lined up with the gaps that are left by the boards.
So he's creating boards going like this, thick things. So he's creating very thick slits and saying anything that comes in sideways, it's going to hit the thickness of the board. And that's not what polarization is, in my opinion. No. It's not the thickness of the filter that makes a good polarizing filter. they can be very thin films, and there's just no correlation between, if I make it thicker, I don't degrade its performance in some way. I don't change the polarizing filter's function any. So clearly the thickness of the material doesn't have anything to do with how the polarizing filter works. The key ingredient is the opening. How thick the opening is, not relevant.
Okay, so yesterday I decided to go make a model of this. So I see Phil, you've raised your flag. If you have a question, please put it in the chat. And as well as at the end, if you have a question, please put it in the chat. I am monitoring the chat. But let's see here. Let's see here. How do I stop sharing this here? Okay. So here is my model of a polarizing material, which is just boards stacked on onto each other.
Right. Okay. So just really not consistent, in my opinion, with the evidence. There's no evidence that depth has anything to do with a polarizing filter working or not working, or changing its performance. And clearly, that's what he's implying, that the depth is what's killing the photons. And it has nothing, no, it's just the gap is killing them. I mean, obviously they're going through the gap and they're having a problem with the bars. The bars are disrupting the frequency, therefore breaking the ability for us to see it as what it originally was, because the frequency is broken.
And so physically, this is what most polarizers actually look like. They take a crystal, they stretch it out, and you get a structure that looks basically like this. Now, what I'm saying is that a light ray is like this pencil. You know, literally, it's got an end, a front, it's got a fixed diameter, and it travels.
Right. So it's not like a pencil, in my opinion. It's like the bullet. It's a little clump separated by a distance, and they can be out of alignment slightly, parallel, but slightly higher or lower, and that's their polarization.
Straight, just like a bullet would. So this is a polarizing material here, and if you have your pencils of light and you're just hitting it at random directions here, pretty much anything.
So again, that's not how the experiments are done. All the light has to be traveling in the direction of the polarizing filter. We're not talking about periphery light. We're not blocking the periphery light. That's not what the polarizing filter is doing. Okay, the point is the polarizing filter is blocking light that has some other orientation about it, not a direction from which it's coming from. So there's no evidence that a polarizing filter only allows parallel light to get through. That's a parallel filter. That's not a polarizing filter. That filter will filter for coherency. Okay, the light all being colindered, whatever, they use a word for that, but light that is moving in parallel. That's a filter for parallel light.
Going forward or backward is going to be basically completely blocked. The only thing that's going to get through is that it has to go in exactly parallel to the slots. And so it can go up, it can be going down, it can be going straight through the slots. It has to be going only through, it's limited by going through the slot here. Okay? So you start out with light that's going every which way, but the only thing that's going to come out there is light, which just happens to be.
Right, so it's just nonsense, right? Because we know that we can shoot a laser that's coming obviously from one location, and the light that gets through, it came from that one location, so it all has the same direction. And the polarizing filter isn't just killing the divergent light, you know, the light that's spreading a little bit too angular. So it's just, no, you're wrong. This isn't very good.
Exactly in the same plane as your polarizing material. And, even in mainstream, you hear them, they'll describe it this way. They say this is plain.
No, they won't explain it that way at all. They'll use this idea that the light has a variance in it, like this or like this. It has a variance. Now, they think the variance is some sort of field perturbation. I would argue the variance just means the bullets are on parallel paths, but they're a little bit out of alignment. They're not right behind each other. If they're right behind each other, they call that circularly polarized. But if they're not, then they're doing a little bit of this. There's a little separation between the bullets in their path.
Polarized light, okay? Which means that instead of every which direction, all the light is then restricted to only a single plane, all right? So this is physically what the polarizers are.
No, it just doesn't explain the 50-50 rule clearly the rule is that 50% of the light gets through the polarizer. So you're not explaining how 50% of the light is the right pencil direction. So you're not providing anything that fits the evidence. Where clearly the evidence is that the light that has a wobble this way doesn't get through, and the light that has a wobble this way does get through. This way to this way. So this stuff gets through. Bow tie this way gets through. Bow tie this way does not get through. Or hourglass, or however you want to look at it. Stuff going like in this plane is fucked. Stuff in this plane is okay.
Typically what light is. Now, the premier feature of a polarizer is that if you turn one 90 degrees to each other, it completely blocks all the light. So how does that work? So we have one polarizer here. It's going to restrict it only to the up and down motion. Okay, so what happens is I've then put a polarizer, which is horizontal, and this will now only allow light which will travel in the horizontal plane. So all the light coming out of your first polarizer.
So again, he's somehow his photon has turned into something that's wobbling like this, or how are you explaining this directional problem that the photon traveling millions or billions of light years across space in a straight line, how is it doing all of this crap?
Means that all the light is only going this way. When it tries to go through this polarizer, it is completely blocked. So therefore...
So see, the way he's blocking it is by having it go on an angle into the slit. That's not what's blocking. That has nothing to do with it. It's the fact that it has freedom of movement this way or freedom of movement this way of diversity. So it's accepting things that have some diversity this way, but it will not accept things that have diversity, the wrong way for the filter.
This is a fully mechanical explanation for how polarization works. And as you'll notice, it has not...
Sorry, it's not the only explanation. It's far from the only explanation. That's just such a extraordinarily bravado-y statement to make.
Nothing to do at all with anything transverse wave. The only thing that light has to do...
That's the only right thing he said in this last 5 minutes or so.
In order to be polarized by such a mechanism is that it has to travel like this pencil, right? Just straight, okay?
Which means that a low frequency radio wave has to be miles long of a pencil, some sort of blob of shit, some sort of stream of jello that's miles long. I mean, I originally attempted to make that work in my theory, in my process of trying to come up with an explanation, and it just kept screaming at me, wrong answer, just wrong answer. There's got to be some other explanation, because nothing can create a stream of jello that straight, that long. What can create the 5 mile long pencil? Who can make one of those? Let me see you make a 5 mile long pencil that doesn't break in pieces.
So let's get back to my paper here. Now that I've shown you how that polarizer works, we need to describe a little bit about, well, actually, before I get to that, there's another complicated thing about polarization, and that's something called circular polarization. Now,
so obviously, light that is perfectly lined up, it'll go through any filter. So obviously, if you have a rotating filter, circularly polarized light goes through it, because the light doesn't hit anything because it goes right through the middle. It's straight. It doesn't care about the length or width of the opening. It's not going to be disturbed by that. It's just going to go right through the middle and be fine.
Now, it's typically described by like this picture. We've got this crazy corkscrew thing going on with the so-called circular polarization, and it has to do with the electromagnetic field lagging behind the magnetic field, and we get this corkscrew. So
they end up taking something that's polarized in a direction, their theory. So instead of rotating the filter, which is the truth, they're saying the photon turns, and no matter whatever obstacle it hits, it just happens to turn to the right direction. So if the bars are this way, when the frisbee gets there and it's saying, oops, I'm the wrong way, it'll just wait and turn through. Somehow it'll just spin correctly. and be able to just turn its way through any jail bars. Clearly not the right answer.
Polarization is a thing. So how can we describe that? Now, and I just figured this out yesterday, playing with these materials, because I took apart a 3D glass, and what a 3D glass has is a circular polarizer, and that consists of one of the lenses is naturally made out of two things. This is a regular polarizer. Let's see here. I don't think you can see any polarization effects on that. Okay. And then they have what's called a quarter wave plate. These things are actually sandwiched together, one up against each other. So theoretically, the result of these two lenses together is supposed to be a circularly polarized light. Okay. So, but what the action of this quarter plate is, which is just this square piece here.
Right, is they're just doing the same thing. So they're just creating a smaller grid work that the light has to travel through, which means it can't be polarized. So they're just saying it's not polarized. The bullets are right in a line with each other.
Is that I believe it's just to turn the plane of polarization by 90 degrees. And that's all it does. So what happens is that if you have two pieces of polarizing material, and I don't know if you can see this, and you turn it so that they block each other like that. So that is because they're crossed to each other. So what happens is that when you stick the quarter wave plate between it, what it does is it takes the plane, like if it's going this way, it will flip it so that it's going this way. So now when you insert this, actually you can see that the light then in fact just shines straight through.
So he's just doing the 3 film thing. So it's not a quarter wave. It's just lines in a 45-degree angle. So what you do is you have lines going this way, filters for this. Then you put a 45-degree angle one in, and that allows most of this light to go through that polarizer and get improved to this. And now it'll get through the third polarizer, because now it's within the 44 degrees, 22 here, 22 here. So all you're doing is changing when you straight line polarize it, all the light is within this range. And now when you bend it this way, this light is still just 22 degrees. So the light was improved from 22 degrees to 10 degrees. That 10 degrees now is within the range of the 45 degrees. This will still make it through the filter, and it'll be improved to 10 degrees within 45 degrees. And then the same thing happens when you go the last turn, except you do lose more. So it's better if you create a filter that's at 22 degrees, and then a filter at 45, and then a filter at 90, and then a filter at whatever the number would be, 110 or whatever, and 112, and then so if you use 6 filters, you'll get better results. Use 10 filters, you'll get even better results. So there's probably a point where you're going to lose more than you gain. So an infinite number of filters won't help you, because you're destroying too many right photons, because the filter isn't 100%. It's not a 50-50 filter. But I've already been over that. But again, so that's clearly polarizing filters change the light. They improve it. They improve its polarization. And by improving it, you can change it.
That's kind of hard to see. But instead of being blocked, that's completely blocked. This now will allow some of the light to go through. And I can see it, but maybe you can't. But it's a little bit hard to demonstrate this since I know how the light works behind. But that is exactly what the quarter wave plate is doing.
So again, it shouldn't be called a quarter wave plate. It's exactly the same stuff. It's just that they cut the square part so it fits. It's the same shape, but it's just the same stuff, just cut at a different angle.
I believe actually it doesn't have anything to do with quarter wave. It doesn't have anything to do with electromagnetic wave being retarded behind the electric field.
And it also doesn't have anything to do with circularly polarized light. That filter you created has nothing to do with circularly polarized light.
All it's doing is that it somehow manages to switch the plane of polarization. And so what comes out of a so-called...
I would argue that if you want circularly polarized light, you put the two filters crossing each other, and you'll get the photons that are circularly polarized still get through. Won't be too many of them, but those are circularly polarized.
Circular polarizer is still just an ordinary, plain polarized light. It just switched different angle. And
correct.
So this has nothing to do with spiraling, things like that picture, nothing at all. And I would say that you really can't say that plain polarized light is anything unique, because it's just
circularly polarized. So he said plain, he meant circularly. But clearly, circularly polarized light is a thing. It's probably a very rare thing, but it's a thing. I don't know what use it has necessarily, so that's the thing. It doesn't have any real value, I don't think. I mean, it's not a thing that does something special that the other light can't do, I would think. I mean, obviously, I think if you had a bunch of it, you could probably create a very coherent beam of something, which would be nice, but I don't think you can organize it well enough to do that. Collect it. I don't think you can collect enough of it.
Still a plain polarized light, and I would contend that if you were just given a beam of light that came out of, say, circular polarizer versus a beam of light that came out of just a regular polarizer, I would say that there would be no experiment you could conduct to tell which is which. The only way you could tell you have a circular polarizer in place is by knowing what the original orientation of the...
Yes, they're just declaring it. So, yes, and so the real test is to create a filter for it. And, yeah, and I don't see them doing that.
Polarizer is inside your source. Without that, you would not be able to tell with another polarizer detector what you had. That could have easily been with or without a quarter wave plate. Because the only thing the quarter wave plate is doing is just flipping the plane polarization. That's how it's doing, by 90 degrees. So I'd say nothing tricky about...
All right. Well, I'd say I'm at an hour and a half more, so I guess it's time for a break. And so I did say this is probably going to take a couple of videos worth. But I think it's a really important and interesting subject, getting to the real elemental function of what these perturbations are that come off of things that are affected by electricity and magnetism to real things. Okay, electricity is always connected to moving current through atoms. I mean, moving pressure through atoms. You have to have atoms, a conductor, to move electricity. And magnetism clearly is one form, moving at exactly the same speed as light. So it seems that if light's anything, it's a form of magnetism or charge that has a frequency. So when you move charge at a specific frequency, you have created a light photon. And it just depends on, to get to the ones that are visible, you have to move the charge, you have to change the charge, you have to cycle the charge on and off very rapidly. Too rapidly for us to do it. Too rapidly for us to do it any other way than by allowing electrons to be agitated at a high frequency. But through a mechanism. How to say it? We have to put the energy in to make the effect come out. So again, it's just, there's no way to make it happen either through physically compressing atoms with magnetic force or running a current through a wire and aggravating the atoms. That's it. All right, so till the next edition and such. I should probably change the color of the banner there, but I forgot. So, too bad. Should be maybe a red color for a little bit of a hostile. So I try to go red for more aggressive and other colors for different things. Yeah, but I'm not going to be able, clearly not going to be able to apply these consistently because I continue to fail to do that. So, too bad. Maybe in the future. These color tabs will mean something. Maybe.